Good day, everyone. My name is Khalile Ozeswanda, a PhD student in the Inclusive Interaction Lab at UC Merced. Today, I will be presenting Designing for Everyday Mobility, a market and user-driven study of adult e-scooters. In this work, I collaborated with Serenity Rain Besat and my advisor, Ahmed Sabi Arif. E-scooters are everywhere nowadays, on city streets, on university campuses, and in parking lots. But if you look at the research, almost everything written about them focuses on traffic safety, usage patterns, and regulation. Very little asks, what do those products look like? How diverse are they? And do they match what riders genuinely need? That gap is what motivated this work. To answer that question, we took two complementary lenses. The first being a market-driven analysis where we surveyed major retailers and manufacturers to build a structured picture of what's available commercially. Secondly, a user-driven analysis with a focus group that comprised of experienced writers to understand how people experience these devices in everyday life. Together, those two perspectives allow us to compare what the market offers with what users care about. Starting with the market analysis, we surveyed platforms like Amazon, Best Buy, Alibaba, and direct manufacturers like Apollo and Segway, collecting top-selling models from each. Through iterative bottom-up coding, we found that adult e-scooters don't form a single category, but they form a design space organized across 3 layers. At the top, we have got 6 vehicle classes, from simple kick scooters all the way to mopeds and disability scooters. Beneath that, we've got form factor variations in handlebars, riding posture, and lighting. And at the base, there's a spectrum of accessories and add-ons, which include baskets, mirrors, and turn signals. Critically, this taxonomy is not hierarchical. Any given scooter sits simultaneously across all 3 layers. Once we had the taxonomy, we looked at the raw specs across all categories. The range is striking. Overall speeds run from 5 miles to 70 miles per hour. Travel range spans 15 miles to 90 miles. Weight varies from 21 pounds to 315 pounds. As you can see in the chart, compact portables cluster tightly around commuter-friendly speeds, but mopeds hit 120 miles per hour with an average speed of 78 miles per hour and a maximum reported range of 584 miles, positioning them close to a full electric vehicle. These are not variations of the same product. They occupy fundamentally different mobility niches, yet they are sold under the same e-scooter label. Now the market can tell us what exists, but it can tell us how people experience those vehicle types or devices. That's where the focus group comes in. We recruited 4 experienced riders, all California-based campus commuters, aged 20 to 23, with over 2 years of e-scooter experience. We ran a 1-hour semi-structured session remotely over Zoom, moderated by a researcher who also writes. The session was recorded, transcribed, and analyzed using inductive thematic coding. That analysis produced 6 stable themes describing how participants experience e-scooters in everyday life. The first 2 being efficiency and cost effectiveness, explaining why people adopt e-scooters in the first place. They cut commute times and replace costly rideshare trips. The next 2, which are maintenance burden and safety concerns, reveal where the friction is. Tires and batteries repeatedly fail. Infrastructure outside campus feels dangerous. And lastly, the final two, personalization and desired features, show how users adapt and what they wish the product offered. Now let's hear it in their own words. One participant described the time savings as simply a 10-minute walk became, quote, a 2-minute zoom zoom. On cost, replacing Uber saved them $20 to $30 a day. On maintenance, one writer said they became, quote, a whole mechanic, changing tires, batteries, and chargers multiple times. On safety, back roads with no sidewalks, especially at night, felt genuinely dangerous. And on what they wanted, turn signals so that cars know that they are turning, and lighter scooters with the same efficiency. What's striking here is that none of these concerns are about speed or range. They're about durability, visibility, and trust. And that brings us to the central finding of this paper. The market competes in speed, range, motor power, and battery capacity. That's what drives product differentiation and what dominates online listings nowadays. But users prioritize something entirely different: repairability, safety communication, such as using turn signals, portability, and everyday usability. This is not a minor gap. Current designs optimize for headline spec sheet at the expense of the things that determine whether a person can rely on their scooter for longer periods of time. From this mismatch, we derived 5 design implications. The first one being design for repairability. We need standardized parts, tool-free maintenance, and clear documentation. The second being infrastructure-aware safety, where we need turn signals and enhanced lighting built in, not bolted on. The third being support everyday mobility, where we need things like cargo and phone mounting, and multimodal compatibility shouldn't be things that come afterthoughts. The fourth one being prioritizing portability over peak for performance. Lighter is often more useful than faster. And lastly, enabling safe personalization. We should give users configurable settings so that they don't have to jailbreak their firmware. To wrap this up, this paper contributes a layered taxonomy of 6 e-scooter vehicle classes, an empirical specification landscape, and a user-centered qualitative analysis revealing 6 everyday experience themes. Most importantly, we have documented a clear and actionable mismatch between market priorities and user needs. Looking ahead, we plan to expand to more diverse populations, older adults, delivery workers, and people with mobility impairments, and to prototype designs that directly address the gaps we have identified. Thank you.